Guten Tag und Mahlzeit. Ich hoffe, Sie werden die nächsten 20 Minuten nicht einschlafen, weil ich eine sehr spannende Präsentation vorbereitet habe. Mein Name ist Dmitry Gorlowski. Ich arbeite im Produktmanagement-Team von Johnson Controls und das Thema meines Vortrages lautet das Potenzial von Absorptionswärmetransformatoren als ein Weg zur Dekarbonisierung von Dampferzeugung. Don't worry, I will switch to English. Ni hao to everyone. Here you can see my agenda. I will start with my motivation. Why does it matter? How it works, possible application, existing references, and future outlook. Let's go ahead. Advantages of Type 2 heat transformer technology is the use of natural refrigerant with zero GWP, which is also non-toxic. It's a thermal-driven heat pump using waste heat, which enables the transition from imported natural gas and oil. It reduces usage of boilers and district steam. It provides high temperature up to 145 and also a high lift up to 55 Kelvin. And it consumes very less amount of electricity, which results in fast payback of such heat pump. Last but not least, it's fully aligned with European decarbonization targets. Let's go deeper in the technology. Most of you are familiar with the Type 1 absorption heat amplifier, with a common use in power station with a combination of flue gas condensation and district heating. Type 2 is more special because we transform a big amount of middle temperature heat into low and high temperature heat with a lift up to 55 Kelvin. Let's go deeper in the fundamentals. You see the simplified schema with the temperatures, temperature ranges, and possible use of each circuit. So, Type 2 heat transformer driven by thermal energy, such as a jacket water from CHP, or solar heated water, or any kind of manufacturing process heating. It uses water as a refrigerant. It provides a low-cost supply of hot water up to 145 degrees, ideally suitable for washing or heating in kind of automotive applications. Or it can be used to generate low-pressure steam up to 2 bar, which can help to decarbonize process steam. This main advantage of Type 2 technology does not require a mechanical drive, like a compressor. It means a very low electricity consumption compared to all other types of heat pumps. The water lithium bromide cycle enables to operate under vacuum instead of under pressure. And as a result, heat transformer does not fall into high pressure safety gas regulations. Additionally, Type 2 heat transformer eliminate the use of ammonia or synthetic refrigerants, providing long-term compliance and safety. Furthermore, this technology can be considered for governmental subsidy programs, which can be used to offset high initial investments cost. Thank you to the colleagues from Fraunhofer Institute nearby here who did this great summary of market segments linked with demand high temperatures. So as you can see here, type 2 heat pump can target multiple industry verticals like food and beverage, chemicals, automotive, and so on. Let's go ahead and figure out how such heat pumps will be selected. Installation possibility of absorption heat transformer can be estimated by using such selection graphs. However, we always need to keep in mind a crystallization line of lithium bromide and set operating points just below this line. So available conditions depends always on cooling water, heat source, cooling water and heat source temperatures. Based on the selection graph, we can make such a table to estimate possible operating conditions. For example, I highlighted in yellow color what kind of cooling water temperatures and heat source water need to be set to create approximately 2 bar steam. Now let's have a look at real-life examples of installation. On the first reference, we use waste heat from CHP system as a driving source to generate 2 bar steam used in manufacture process of automotive factory. This type 2 heat pump improved total system efficiency of this factory from 60% to 70%. And annual running cost of this system was 8 times less compared to previous solution with a steam boiler. And such result make possible a payback of such heat pump in 3.5 years. Additionally, approximately 360 tons of CO2 emissions per year would be reduced. And next reference is from alcohol distillery. Overheated steam from distillation is used as a driving source, and latent heat of ethanol vapor recovered by absorption heat pump generated hot water of 112 degrees and heat up the bottom of the distillation column. As a result, steam consumption of distillation tower could be reduced, and with operating hours of 8,000 per year, annual CO2 reduction was heavily compared to previous oil boiler solution. And last example is a project from chemical industry where the highlight is the use of groundwater as a cooling water, which makes the whole system more efficient. You see also that the picture of the unit installed outdoor in ATEX with ATEX requirements. So it's kind of Champions League in the case of complexity of installations. At Johnson Controls, let's finish with outlook and conclusion. And at Johnson Controls, we continuously improve and develop new products. And next year, we will launch a new generation Mod B Type 2 heat transformer, which you can see here on the slide. It will benefit significantly the footprint, weight, and will be much less challenging in manufacturing. To take everything to a conclusion, we can say that we have a multiple references in operation over many, many years. So the performance of this technology is proven and it's reliable. And the main benefit, we can create a high temperature with a high lift. And I see a bright future for Type 2 Mod B design of Johnson Controls heat pump. And my last message is, don't waste your waste and use a heat pump. Thank you so much for your attention. Here you can see my references and my colleague, Fuji-san, who helped me with the inputs. I'm glad to answer your questions.